Continuing on with our discussion of reaction mechanisms, one important equation we need to know that relates temperature, activation energy to our rate of reaction is the Arrhenius equation. This is K equals A E raised to the negative activation energy divided by RT. So going through each one of these variables, K is simply our rate of reaction. So little k will tell us how fast this reaction will proceed. A is called the frequency of collisions constant. The frequency of collisions constant. So if we have the reaction A plus B goes to C plus D, in order for this reaction to occur, A and B need to come in contact with each other in the correct spatial orientation in order for them to fit together and form our products. So this factor A tells us how frequently we can find A and B molecules in this reaction coming together in the correct spatial orientation to form our products. So that is A. E is simply the base of natural log ln. So ln is natural log and E is the base of that, raised to the negative activation energy, which we covered in this module, which is the amount of energy reactants need in order to overcome the energy barrier of that reaction and proceed to the products. R is the ideal gas constant. This is 8.314 joules per mole times Kelvin. That is a constant, and temperature will be temperature that we run this reaction at. So looking at this equation, how could we speed up the rate of our reaction? Well, one thing we could do is lower our activation energy. Now, when we lower our activation energy, this is the numerator, but it is the negative value. So you are making your numerator a smaller negative value, which is actually in turn a larger number, which will increase the rate of reaction. In the same light, increasing the temperature will also increase the rate of our reaction, because what this will do, it will make this overall fraction a smaller number by increasing the denominator, but it will make it a smaller negative number, which is in turn bigger, which will increase the rate of reaction. We cannot change our R constant. It is 8.314 joules per mole Kelvin, and we will not change our frequency of collisions constant. So this equation essentially equates activation energy and temperature to our rate of reaction. And we know that decreasing our activation energy and increasing our temperature can get us a faster rate of reaction.